Hi, so I'm going to talk to you a little about enzyme inhibition. So we've got enzyme inhibition. All right, so again, remember the general transition scheme. I'm going to write it again. So we've got E equals enzyme. So write E equals enzyme, S equals substrate. Is this what you had? Mind reader. Okay, so basically the way we're going to do this again, just to remind you, this is the normal. This is the normal reaction scheme. And so what we have normally is that the enzyme plus a substrate is going to go to an enzyme substrate complex. It's going to be converted to the enzyme plus a transition state, which is going to be converted to the enzyme product complex, which is going to be converted to enzyme plus product. So this is the transition state. So this is following along. I'm sure all of you are following along at home. So this is what we have. Those dots mean complex. Okay, so this is, you'll remember this from a couple lectures ago. This is the general reaction scheme for an enzyme. So now we're talking about enzyme inhibition. It becomes more complex. So the most common type of enzyme inhibitor by far is a reversible inhibitor. So for reversible inhibition, we're going to recall that. So for reversible inhibition, we're going to so if we take that same equation, and I'm just writing plus S and minus S over that arrow there. And the reason I did that was that with or without the substrate, it would go back and forth. You know what I mean? From the complex or to enzyme and free to the complex or to enzyme and substrate. So if we add, so I'm going to say for reversible inhibition, we're going to add inhibitor I. And so when we add I to this equation above, we're going to have a new equilibrium with that enzyme and substrate. So every time that substrate comes off, so if we add I to that equilibrium above, then every time that enzyme binds the inhibitor, we're going to go to an enzyme inhibitor complex, so the EI complex here. Every time the inhibitor falls off, we go back to free enzyme that possibly could bind with a substrate, or it could bind with an inhibitor, because you're not getting rid of the substrate, right? So we're just adding something that complicates. We're adding a new equilibrium on to this mechanism. We're adding a complicating factor, basically, to this equilibrium. We're adding another one in here. And so this is going to be the K on, and this is going to be K off. So we have K off on the one side and K on. And the Ki is going to be K off over K on. And so the smaller the Ki, the tighter the binding, the more effective the binding.